Hi, students. Welcome to video 20 on the pesticide dilemma. Just some facts for your information. You don't need to write any of this down. 3 million metric tons of pesticides are used annually on Earth. 25% in the U.S. are used in our houses. So houses, gardens, lawns, playing fields, swimming pools, golf courses. That's where most of the pesticides, or a fourth of the pesticides, go. The rest of it are going to be for agricultural purposes. And the average U.S. homeowner applies about 2 to 6 times more per acre than a farmer would, because we think that we should use more. In reality, it doesn't take as much as people actually think. So a little bit of history. Before the 1950s, farmers actually used arsenic, lead, mercury, things that they got from minerals. These were our first generation pesticides in most cases. As you can imagine, not the best thing in the world. We started using synthetic pesticides, that were made in the lab, and this doubled our food production in developed countries, and it increased it by 120% in developing countries. So these chemicals have been really good in terms of feeding the population of the world. Remember those almost 7.5 billion people that we have. Otherwise, we would not be able to do that. So here are some of the different classes of pesticides. I don't really think you need to write this down. Most of them are pretty obvious. So insecticides kill insects, herbicides for weeds, fungicides for fungi, nematocides for roundworms, nematodes, rodenticides kill rodents, algicides kill algae, and larvicides kill larvae. So something you need to know, narrow versus broad spectrum pesticides. So a narrow spectrum is going to kill only the target species. Broad spectrum is going to kill a variety or a lot of different species. So narrow spectrum is good if you have a specific target that you know is the problem. Broad spectrum might be good if you're not really sure and you just have problems with insects eating your crops, but you don't have a specific one. So narrow spectrum is more what we want to use, because if you use the broad spectrum, it's going to kill everything, even including the good things involved. So some of the disadvantages and advantages, of course, with everything, you need to know environmental, economic, social advantages and disadvantages and be able to discuss it. Some advantages are it does save lives because it allows us to grow more food, and that in turn saves a lot of lives. People don't die from starvation if you can grow more crops. It is profitable, so it gets you a lot more money. They tend to work really fast, so they'll kill off the insects really quickly. And it is safe if used properly and you don't spray them, more so than what you would actually need. Some disadvantages, it does promote genetic resistance. Something we call the pesticide treadmill is this idea that, I spray chemicals to get rid of this pest, but then the pest becomes resistant. So I spray more of the chemicals. I spray a higher concentration of the chemicals, and then the pest becomes resistant again. So you have this cycle, this treadmill, if you would, of continuing to having to use more harsh chemicals, more concentrated chemicals to kill the same pests. I also end up killing native pests that are good, and I can create like these super bugs with that genetic resistance. I also pollute the environment, the air, the water, and it can harm people and wildlife if used inappropriately. A little fact down here for you. The pesticide industry declares that the health risks are insignificant compared with the benefits, which of course they would say that. So some harmful effects on the ecosystem. Pesticides can be persistent, meaning that they remain in the environment for many, many years. They can also bioaccumulate, moving up the food chain. So each organism is going to have more of the persistent pesticides, such as DDT, in their bloodstream than, lower things on the bottom that we've talked about before with biomagnification. Children and the elderly, like usual, are the most at risk, but it's a greater threat to children because they're playing on the floor, they're outside playing on the lawn. Maybe not as much now. They're inside on their iPads, but saving you from pesticides, I assume. But their brains and their bodies are still developing, and so as they're getting around on the floor and the lawns, they're inhaling these things and it's causing them to have issues. This does affect your intelligence and motor skills. It's been shown to, even in older people, possibly be linked to Parkinson's disease. And so we're investigating that right now. What is the ideal pesticide? Well, it would kill only the target species. It would disappear quickly in the environment, so it wouldn't be persistent. It would also break down into something harmless because some things do not. They actually break down into more harmful substances. It would also not cause genetic resistance, and right now there is no such thing on the market. So if you can design this and market this, you would make millions, if not billions, of money if you could make this ideal pesticide. Specifically, DDT. This is one that was used a lot in the 40s, the 60s. We would use it in agriculture, and we used it in areas that are ridden with diseases because it can kill things like mosquitoes. So if you're living in some countries like South America, Africa, some of the Middle East areas too, these mosquitoes are really awful and they transmit malaria, which is a disease that causes a lot of deaths per year. So if you spray DDT, it will kill the mosquito and prevent you from getting malaria, but then you're left with the DDT. So it's kind of a trade off here. Would you rather have the pesticide poisoning and the neurological problems that come with that, or would you rather have malaria, which could cause you to die much, much earlier than you probably would normally? So DDT is very persistent. The other problem with it is it breaks down to something even more toxic, which is DDE. So, we want something that breaks down into harmless things, not something that's worse. And we know DDT accumulates and biomagnifies in the food chain. So what does it do specifically? Well, it blocks calcium formation in bird eggs. This was the thing that Rachel Carson kind of figured out. Why is the spring silent? If you remember her Silent Spring book. The eggs are then thin because they can't make the calcium, and so they break really easily. So in other words, the eggs do not last long enough for the baby birds to actually survive and hatch. They basically end up like cracking open, really easy for predators to get to them. And this caused the bald eagle to go almost extinct. Luckily, we kind of reversed this problem and we realized that DDT was doing this. So again, please remember Rachel Carson and DDT. Her book was Silent Spring. This is just kind of some for your information stuff over here. In 1958, it was sprayed to control mosquitoes near bird sanctuaries, and we noticed that the birds were dying. And this is a quote from the book: "For the first time in the history of the world, every human being is now subjected to dangerous chemicals from the moment of conception until birth." So this is, we see things in our system already, and we're not even always sure what they do. But usually if you've got chemicals in your body from outside sources, not going to be a good thing. So some opposition to her book. The public was really, embracing of this. They really liked the book. They realized what was happening. But the chemical industry, as you can imagine, not so much. They used a lot of money, $250,000, which back then was a lot more money than it would be today, to discredit her. And they called her, or they said, as a woman, she was incapable of understanding the highly scientific and technical subject of pesticides. Sorry, ladies, but that's the way that women were looked at back then. Now we know better, and we would not, hopefully we would not say such things, even though sometimes it still happens. Unfortunately, 18 months after she published the book, Rachel Carson ironically died from cancer, possibly from pesticide exposure, but we can't really say that. So looking at DDT in the US now, it was banned in 1973. However, we still actually make it and we send it to developing nations so that they can use it to fight malaria and to also grow crops. We are the largest manufacturer of DDT. And just because we're not actually putting it on our food does not mean that it doesn't still get in our food. So we import food. If we're importing from a place where we are sending DDT, then you bet there's DDT on that food. It also travels through wind belts around the world because it gets sprayed and put in the atmosphere. So it's not just, over in some other country and it's not affecting us at all. It is still impacting us. So the last little thing we're going to talk about is integrated pest management. What can we do besides putting chemicals in our food? So these are your four strategies for integrated pest management. The first thing is cultivation methods. So we don't want to do things like crop rotation, contour plowing, adding nutrients to the soil with fertilizer, manure, those sorts of things. that we can do. And if we're doing things, polyculture instead of monoculture, that will decrease on the amount of pests that we have. So that's our first step. If you're doing crop rotation and you still have problems, then now you can mechanically remove pests. So that's what you see this farmer down here doing. He's actually walking around with a net and he's capturing bugs. This over here is the same kind of thing, except it sits in place and bugs get stuck to it. You've probably seen those before. If that doesn't work, then you do biological controls. What that means is you bring in the predator of the pests. So maybe you bring in birds or you try to do something that will bring them in and they will kill off the insects themselves. Your very last resort is going to be chemical control. So this is the very last thing that I want to do. I've tried cultivation, mechanical, and biological controls, and nothing has worked. So now I want to spray pesticides, but again, I want to do it smart. So I don't want to use more than I have to. I use the very limited amount that I need. And some laws regarding pesticides. You have FIFRA, the Federal Insecticide, Fungicide, and Rodenticide Act. Basically, this is the EPA creating tolerance levels for different pesticides and trying to manage pesticides. All right, that's it. Bring your questions tomorrow and be ready for a quiz.